In this section, I'm going to show you how to work with formulas. In particular, we're going to manipulate formulas so that they're solved for a given variable. So if you look at number 1, and by the way, as we do this, we're just going to be using our equation solving skills. It's a little bit more complicated just because we're working with mostly letters, but we're using the same skills that we use to solve equations. So let's look at number 1. If we're solving for h, that means we need to get h by itself. So how do we get rid of the b? Well, it's b times h. The opposite of multiplying by b is dividing by b. So we're going to divide each side by b. And on the right side, the b's are going to cancel and we're left with h. On the other side, we're just going to write a over b as our final answer there. Now you can write the h on the right here, or if you prefer, you can put it on the left. It's probably preferred to be on the left, but it really doesn't make that big of a difference. I don't care which way you write it, and I'll do it both ways. On number 2, let's see, I need to get t by itself, so I need to get rid of that r. So it's just like number 1, we're going to divide both sides by r. By the way, as I'm doing these, I would encourage you to watch how I do perhaps the odd ones and then maybe try the even ones. So let's just go ahead and see what you got here. The r's cancel. You get t equals d over r. Now number 3 and 4 are a little bit different. Think about what we do when we have fractions. Remember the CSI? The C was clear fractions. So anytime you have a fraction in one of these types of problems, I would encourage you to clear it out first. So if you look at number 3, the LCD of the denominators, there's only one, is 2. So let's multiply each side by 2. We're going to get 2a on the left. Now keep in mind, when you multiply 2 times a half, you get 1. They're reciprocals. Reciprocals always have a product of 1. So what you're left with is 2 times a half, which is 1, times bh. So we get bh on the right. And so now we need to get h by itself. We've got to get rid of that b. We'll divide each side by b. The b's cancel. We're left with h equals 2a over b. Let's look at number 4. And again, I would encourage you to try it before you look at my solution. Let me go ahead and do it now. We're going to this time multiply each side by 3. We're going to get 3a equals capital BH. And if I want that b by itself, I'll divide each side by h. And so we're going to get capital B equals 3a over h. Number 5. Well, let's see, we need to get rid of the L and the W, and this is all multiplication. So I'll need to divide by L. I'll need to divide by h. And let's do that on both sides. Notice the L's cancel, the H's cancel. We're left with just a W on the right. On the other side, you have V over LH, and that's what W is equal to. So again, try number 6, and then check the answer. All right, so here, if I want R by itself, I've got 2 pi times R. So let's just divide each side by 2 pi. We are going to get r equals c over 2 pi. All right, let's move on. On number 7, actually quite similar to the one we just did. This time I need to get rid of the pi r squared. So you should divide both sides by pi r squared. So the pi r squared parts cancel out. You're left with h on the right. On the other side, you have v over pi r squared. Now when you get to number 8, things are a little bit different here. If we're trying to solve for m, the first thing I want to do, I'm going to have to get rid of each of those c's. But this is kind of like a two-step equation when we're solving equations. We want to do addition or subtraction before we do division. So I want to get rid of that c first, that c term, by subtracting c on both sides. So notice now I've got the m times c, and I'll do my division next. I've got to get rid of that c, so I'm going to divide by c on each side, and so we're going to finally have m by itself equal to p minus c over c. On number 9, if I'm solving for t, I need to get rid of that b term, and so now I have the mt by itself, and to get rid of the m, we'll divide each side by m. We're going to get t on the right, w plus b over m on the left. On number 10, and actually if you want to challenge yourself, try this one, and then you can check my solution. Alright, so you should have multiplied each side by 2. We're going to get 2a equals h times the quantity a plus b. If I'm going to solve for b, I need to get that b out of parentheses, so let's distribute next. Get h times a and h times b, so ha plus hb. And I need to solve for b, so I need to get rid of the ha term. So on the left I have 2a minus ha. Notice a capital A and a lowercase a are treated differently. Can't combine these terms in any way. The only thing I can do if I'm trying to get this solved for b, I'm going to have to divide by h. And I'll do that on each side. The h's cancel. And we're left with b is equal to 2a minus ha over h. Alright, so as we get further along, you'll see things get more and more complicated. Let's look at number 11. 11's not too bad. Let's see, we need to solve for t, so let's get rid of that p term. So we have s minus p equals prt. So now the pr is multiplied by t, and I need to get rid of that pr. So we want to divide each side by pr. So the prs cancel. We're left with t is equal to s minus p over pr. Number 12 is another one where you need to clear the fractions. So let's multiply each side by 1 minus r. So on the right, the 1 minus r's are going to cancel, and you're left with c. Now on the other side, make sure you distribute the s times 1 minus r. You're going to get s minus sr is equal to c. Now keep in mind, I'm trying to solve this for r. So let's see, I need to get rid of that s term. I'm going to get minus sr is equal to c minus s. And now I just divide by a minus s. Now the problem here is maybe not so noticeable, but we don't normally have a negative number in the denominator of an answer. So this is not an answer that you would see in my math lab or perhaps in the back of a book. There's a little trick we can use to get rid of that negative in the numerator. We're going to multiply this expression by negative 1 over negative 1. So what happens when you do that, you're going to end up with a minus c and a plus s, and we'll write that as s minus c. In the denominator, a minus s times a minus 1 gives you a positive s. And so this is how we would write our final answer. Alright, we've got 2 more. And again, here's where things start getting a little more challenging. Look at number 13. We're supposed to solve for p, but p is in both of the terms on the right side of this equation. So how do we get p by itself? We can't combine these terms because they're not like terms. We don't really have a nice way to combine them. But think about this. We learned a technique called factoring out a GCF, and on the right side there's a common factor of p. So we're going to factor out a p. P times 1 would be the p, and p times rt would be the prt. So all we've done is factored the right side by factoring out a p. On the other side we'll still have s. And so now it's quite easy to solve for p. I just got to divide by 1 plus rt. And so those 1 plus rt's cancel. You're left with p on the right, and then s over 1 plus RT on the right, on the left. Okay, number 14. So here we have 3 different variables in the denominator. R sub 1, and R sub 2 are all different. In this formula, for whatever reason, they write these variables using a capital R with subscripts. So we're going to have to include all these variables in our LCD in order to clear fractions. So I'm going to rewrite this where I'm multiplying the LCD times each of my 3 terms. So look on the left, we've got our LCD times 1 over R. Notice the R's are going to cancel, and we're left with R1 times R2 times 1, or just R1, R2. On the other side, let's see, when we multiply times 1 over R sub 1, the R sub 1's are going to cancel. And we're left with R times R sub 2. And then the last, when you have 1 over R sub 2, the R sub 2's are going to cancel. Whoops. And you're left with R times R sub 1. So we've first cleared the fractions, but we have a lot more work to do because we need to solve for R sub 1, and there's 2 terms that have an R sub 1 in them. So this is going to be like the last problem where we're going to need to factor out an R sub 1, but the first thing we need to do is get these R sub 1 terms on the same side. So I'm going to go ahead and subtract R1 from each side. And so notice now my R sub 1s, that's what I'm solving for, are both on the left. And so now I can factor out an R sub 1. So we have R sub 1 times R sub 2 minus R is equal to R sub 2. So finally, I can do division to get R sub 1 by itself. So we'll divide each side by R sub 2 minus R. The R sub 2 minus R's are going to cancel on the left. We're left with R sub 1 equals R times R sub 2 over R sub 2 minus R. And that's it.